And the driver lineup you'll see here today is going to be expanding. We're going to be adding some more drivers, as well as probably some that you were not aware of that we had on our offering. So let's get started. So this is training number 6. We have 2 more to do after this. We'll be back on track now. Call to travel. We'll have the 21st. We'll have understanding LED part numbers, and then the 28th we'll go over some TM30. Goals are pretty simple. Review our drivers that we have. Find out some of the new drivers that we'll be offering. Understand how different module configurations determine the actual driver selection. Examples about modules and how the currents add and voltages add. And then some of the software tools they have available to assist you in the module selection. We'll get started there. Driver lineup. This will be a pretty quick one today. I don't think it'll take near the 30 minutes we have. So many of you are familiar with our standard driver offering. These are more RSET type drivers, and that's been the bulk of what we've had to offer. We have this 15-watt driver here. It's more of a square footprint, and it was more for like downlights and some of our LED type spotlight modules. But certain fixture applications, there are some of these available as well. I mean, they will fit if it has room in the fixture for it. So free to use it in any application, really. Moving. So we have 15-watt device. And also have it in a 30 device. And these are in the same size footprint. The dimensions are roughly 123 millimeters by 79 millimeters, roughly by 33 millimeters in height. So you can use these in other applications as well to use them where they will fit. They operate all the same. They have an RC that can set the maximum output current, and then you have a dimming input as well. 50-watt version of our RSET driver. It's a slim design, so it's really more for like trotters and that type of product. And we also offer that in a 75-watt. The difference here is in the dimming output current range. The voltages range are all the same. We just increase the output current, and the minimum output current goes up as well as the maximum output current. All RSET, all 0 to 10 volt for dimming. So drivers we have now is our 75 and 96 watt programmable drivers for industrial type applications. These are in slimline form factor as well. They're a free programming tool that we offer to customers so they can do the programming of this particular driver. It uses a software that is downloadable from our website, and it sets power off the USB port and powers the driver while programming. So these drivers do not have to be connected to high voltage or 120 to be programmed like some of the competition's drivers do. Are more for industrial. You notice they have much higher surge rating than some of the other drivers on the market. Just on these, they will be offering this in the future in a 50-watt version, available after middle of this year. But right now we have the 75 and 96 watt available today. Also, the drivers are included in our industrial module kit, along with the programming tool. Many of you have probably already received one of those kits, but if you don't have one, let me know, and we get you one of those kits, and then you'll have the programming tool, both of these drivers, and a collection of our influx modules for testing. So, possibly May of this year, if everything works out well, we'll be able to offer a what we call a low-cost driver. And these drivers are available in a 30 and 50 watt configuration, also a non-dim and dimmable version of one of these drivers. And so this makes them a very low-cost, low-cost driver option for your customers. So you can have non-dim and dimmable down to 5%. And they're in a small form factor, lower than the typical slimline, but much shorter, about half the length, only 165 millimeters. So we'll get pricing out on that, and once they get added to the price book, be on the lookout for these new low-cost drivers. I have a few samples here in the office, but don't have any in high enough volume really to give to customers yet. Also, many of you guys may know that we have some fixed output drivers for outdoor applications. A wide range of these, and these work well with our outdoor IP66 rated fin drivers and finless modules as well. So here's a wide range of fixed outputs and set currents, typically on 700 milliamp increments. So 700, 1.4, 2.1, 2.8, 4.2, and 5.6. These gang together your modules, and then you can use this fixed driver to actually drive that whole together. And this people would use. These are all rated IP67, waterproof, and anti-dust. So they're used in outdoor fixtures with no problem whatsoever. I'm going to go through a little bit. That's kind of the drivers that we have, and wanted to focus a little bit on here from the current and voltages of a driver that is needed in certain applications. So I'm going to do Phonics 101 here. So let's start with the basic element of a module, which is the LED itself. And so just find that your typical LED is a diode, and that diode happens to produce light at its P-N junction. So how does it create light? I'm not going to go into that detail here, but basically you can think of it as we push current through the light, the electrons jump across. They jump across the band gap that determines the wavelength of the light that's produced. So the forward voltage is on average around 3 volts. Now, our LEDs typically are slightly lower than 3 volts, but for the most part, we're going to use 3 volts as our general voltage to keep the math simple. So let's forward at how you create a module. Basically, if I take the LEDs, I can put the LEDs in parallel or series. And if I put these in series, so each LED is going to add. So a drop on 3 LEDs as shown here would end up being a 9-volt drop across the string. This is what the bill would have to look at. Or the LEDs in parallel. And if I put the LEDs in parallel, the current is going to add. So those are the 2 basic rules. Voltage adds when LEDs are in series. The current adds when the LEDs are in parallel. So it's very simple. So then that, and I say, okay, let me put 8 LEDs in a string, 3 strings in parallel. The voltage would add up. 8 times 3 is 24, so I'd have 24-volt drop across each string. And the strings in parallel of 150 milliamps each would be 450 milliamps total. That's what the actual driver would have to provide. It'd have to provide a minimum of 24 volts and current of 450 milliamps. And that is what our M series is. That exactly gave you is basically our M562A module. Your M562B module here has 4 strings. It has 32 LEDs, and the 562C is basically 2 562As together. If you actually look at a board, the D board and the A board are the same PCB. We just populate every other LED to make the A. So they're full, and then this determines the driver's requirements. So that's here. This is just a module. So a fixture have a combination of these. So the same thing holds true when you take it to the module level now. We take two modules in series. Therefore, their currents, if you put modules in parallel, their currents would add up. So the rules apply as it did on the diodes as it does at the module level. So you hear that two 562Bs in series would be 24 plus 24 would be 48 total volts. And parallel would be a total of 1200 milliamps required by the driver. So the driver itself would have to provide these voltages and currents. You can do combinations of the two, and this is what we see typically in a lot of fixtures. Here would be an example where a customer was trying to get about 8,800 lumens out. He's going to use 4 5B modules. He's going to take 2 of them in series and put 2 of those series strings in parallel. So it's a combination of the two. So the forward voltage across these two would be 48 volts. The total of each string would be 600 milliamps each, which would add together to produce a total of 1200 milliamps. You would need a driver that could provide 40 volts at 1200 milliamps in order to power this particular application. How about that? Well, we have software tools that are available. And so you actually go through the software tool. This particular tool is our Circle M 0.0. It's the latest version. It basically provides you analysis and designs using modules instead of individual LEDs. Over to that application. I hope you can see this. I'm running the Circle M tool right here, and it's straightforward and pretty simple. You just select your module that you want to design with, and I'll use the same one we did in the example, which will be 562B. This is new, as you can see, and it automatically fills in all the specs and information for you. You select your CCT, typical forward voltage and flux rank, and again your current level in amps. So I'm going to do half an amp, 600 milliamps. And so as you can see, it actually populated what the actual part number would be based on these requirements. So to figure out what the exact part number is, this is also a useful tool to do that. What the actual flux level would be, and for each of those driven at that current, what the forward voltage requirement would be, as well as wattage, and then actual efficacy levels. Down here at the bottom, I'm going to string these together. So just as in our example, I'm going to put 2 module series, and then I'm going to have 2 parallel strings of those as well, and they give you the total current required, actual flux level, and the lumen output that you're going to get of the total system. And that's very handy. So you can come here and enter in the optical efficiency. So we'll just enter in and drive efficiency of 88. You can see what your level output would be. And this is one way to use this tool. We also have the capability of doing it by targets or lumen per watt targets. So same experiment here. So we're going to grab the same module, the B module, and do 4,000 Kelvin, ACI, always typical, and now again my flux target. So let's say I wanted to have a raw flux output of 4,000 lumens. plug 4,000, it gives me a range down here of efficacy that I can actually work within. So I'm going to, let's say, for example, the PLC target of 110 lumens per watt for a thumb fixture. And I'm going to operate that at, let's say, 40 degrees Celsius. It tells me, based upon an opt efficiency of, let's just make this 90 like before, and 88. So exactly how many I need in order to achieve this particular output. And you can see I can actually accomplish 4,000 lumens at 110 lumens per watt with 90% optical efficiency and 88% driver efficiency. I will get to drive them at about 700 milliamps and 25 volts forward voltage. Each one will be outputting roughly 18 watts. And total efficacy at the fixture level of 130 lumens per watt. I only need 2 in order to accomplish that particular application. A very quick and easy way of doing it, and you can do side-by-side comparisons with the second module. So maybe you want to try it with C module to see if I could do something else. So that's basically how this tool works. The other tool, based on quantity, you'll be able to pick how many and then pick your measurements. I'm not going to go into that kind of detail. You can play with that at a later time and see that. But it's very simple and very quick to get to a solution. You can go is at our website. Not be aware of this, but it's on the website. We'll go to the page here first. On our home page, in a little bit there, home page, we have products tab where people normally find information about our product, but over here we have one called support. And under there's a tab called tools. If you'll actually one for calculator for engines. Click on that. You get the same tool that I just showed you in the Circle M 3.0. The difference here is that this tool gets updated a little bit less often than the 3.0. So the 3.0 tool is our latest, and then eventually it gets migrated over here. But it works similar. You're able to plug in which you want. So you use from the list here. Just grab one of the quick. Choose your CT, your I. Always cool. And then it'll actually give you the part number, give you specs on everything here. You're allowed to come down here and do an actual design. Your system configuration, so let's go back with the 2x2 application. And optical efficiency of 90%. And driver efficiency of 88. Full system performance. A nice thing this tool does is it also makes a recommended driver selection. Specs there based upon that particular driver as well. So you can actually look at which driver can actually be used to match up to that particular application. Pretty neat. Another nice feature is that I actually found this kind of useful. I'm able to kind of pick and choose. I can actually tweak to see, well, what happens if I lower my forward temperature. I can see what my lumen output does and how it affects my efficacy just by playing with these dials, and it adjusts accordingly. Same with the drive current. You can lower the drive current by just 1 milliamp at a click. You can see the forward voltages would change, as well as the actual efficacy will keep going up as I lower that. It's really a handy little tool to get a good understanding for how the LEDs can be driven, and you can pick and choose and determine what the optimum drive condition. So Go back to the presentation now. Go here. So that training today, like I told you, it wouldn't take that long. Training next week will actually be on our AD part numbering.